Okay, so transformations. You talked about horizontal and vertical transformations on a quadratic last year. And we're going to do transformations and then stretches, I believe. Or transformations and reflections. I can't remember which one. Reflections, that was right. Okay. So, translation. A translation is a transformation that slides each point of a figure the same distance in the same direction. So what happens this year is not only do we add a horizontal stretch and we add a reflection in the y-axis, and reflections in the x-axis was there last year, but what we have to do too is that we have to make sure that we understand everything fully as we're going along, because when I put all the transformations together, that's when it gets dicey. Okay? So as we're going along, they seem really, really easy. So you have to practice it really well and know exactly backwards and forwards as we go through the next 3 lessons, because they seem easy because they're standalone. And then we put all the transformations together and then it gets a little dicey. Now, last year you only did transformations on a parabola, on a quadratic. That was it. This year we're going to transform any function in the world that they could give us. So they could give us just even something that looks like this. That passes the vertical line test, so it's a function, and we have to move that, right? They could give us whatever they want, and we have to move it, which means they don't have to give us an equation, because that doesn't actually have an equation that fits it. It would just be 3 piecewise functions together. So, in general, we can get this in this form or in this form. Do you see how there's this little f in there? Do you see that little f in the equation? That's what's going to change from last year. Because last year it was always applied to a quadratic, where from x squared to some sort of like y equals x plus 3 squared minus 2 or something like that. And we say the transformation from a base parent function x squared to something we moved. This year we can move any functions. So what they'll do is they'll start off with the original function is y equals f of x. And then it's transformed into some sort of y equals a f of x minus h plus k or something like that. So this little f throws people off. Do you know how we can state our transformations? Like there's a vertical stretch by a factor of 4 about the x-axis. It's horizontally translated 3 to the right. It's vertically translated 2 up. We can say the words, right, of the transformations. This is just another way of saying the words. This is the f function. Okay. This is the f function, and this f function is being transformed in this way. So instead of having an f, they could have a g there, right? Because it could be a g of x graph. And this year we're not going to just talk about f of x, we could have g of x, h of x, m of x, because what can happen is we can have a few graphs, like we have this graph on here, okay, well that's f of x. We could have this graph on here, okay, well that one's g of x. And then we could have another one on here, okay, well that one's h of x. So it would apply to whatever graph it's applying to, right? So if I have an f in it, it's being applied to the f of x graph. If this was a g instead, it would be on the g of x graph. If that was an h, it would be on the h of x graph, right? So that's all that little f means. Also, if there's a little f in here, you cannot type it into your calculator. That's also what it means. If there's an f here, it can't be typed into your calculator. So last year, you guys could always type it into your calculator, and if you forgot how to move it, you could very well look and attempt to guess what was happening for transformations. You can't do that this year, because sometimes they just give you a graph that doesn't have an equation. But what we do need to know is that when it has this f in here, it can't be put into your calculator, and it's just another fancy way of giving you the transformations. So if there's an f, those are just the transformations in equation, not words. That's all this little f does. It's just another way of saying the transformations. Instead of words, they give it to you as this little equation. So if the f is in there, it's literally just transformations straight up without writing them in words. So we could have it in the form y minus k equals f x minus h, or y equals f x minus h plus k. You could do that. I will always turn it into this form. I always get my equations into y equals, and then follow the same rules every single time. Do you remember last year when you did caveat? When you were given, nope, I wanted to add a page. Y equals 3, x plus 6 squared minus 5. Do you remember what the vertex was?
-6, -5.
Yep. Why was it -6 and the 5 stayed the same?
Because you're minusing the number. So if you're minusing a -6, then it becomes positive.
Yep. Because the equation is y equals a x minus h or p, whatever you used last year, plus k, right? So if this one has a hidden minus sign in it already, right? So in order to get x plus 6, it's not actually x plus 6, it's x minus -6 squared. So that's why it's actually 6 to the left and not to the right. Because the equation is x minus, and then I put whatever the heck h is, right? So in order to get a plus 6, it's actually x minus a -6. So that's why you actually move 6 to the left. And that's why your vertex is -6, not +6. Now this one's a plus k, so I could just put a plus sign in here, and then this would be my k. So that's why you keep that one, correct? But the h switches because of that minus sign in there. Do you remember that? So same rule goes for transformations of all functions. This one will always go in the opposite direction, and this one will always go in the same. This one is a what affects the what variable?
X.
And this one affects the?
Y.
So this one is going to move which way when it affects x's?
Left.
Left or right, in this case left. And this one goes down or up. Yeah. So that's what we're going to talk about today, is literally just left, rights, up, downs, transformations, and then stretches as well, because we're doing the double lesson. So here it says the little summaries of your H's and your K's. Here it says mapping and replacement notation. So this year we actually add mapping and replacement notation too. Mapping notation is used more often than anything because it's literally just how would the coordinate move. So I to have a coordinate xy, how would I move it? So this one here, it says the graph of y equals f of x is transformed to the graph of y minus k equals f of x minus h. Well, I would rewrite that as y equals f of x minus h plus k. I'm horizontally moving this what? H to the where? Is it right or left? It's right, because this is x minus, and then this is what I'm actually looking at, which is a positive h, right? So I'm moving h to the right, and this one I'm moving k what? K up. So if I went to go take a mapping, I went to go take, okay, my original point is xy, it becomes, and that's how you have to do mapping. Xy becomes, that's what that little arrow means. Xy becomes, well, what do I do to my x? I moved it h to the right, correct? So how do you move to the right? Add or subtract? Add. I'm a little xy point. I feel like I'm a little teapot. That's where I was sitting. I'm a little xy point. I want to move h to the right. So I have to do what to the x? I have to add h, correct? And then I want to move k up, so I'm going to add that to my y. Because the only way I can move up or down is with y values, and the only way I can move left or right is with x values. And we'll talk about replacement notation after. So say I give you this one, the graph of f of x, whatever f of x is. Do I even need to know what f of x is? F of x could be a quadratic, f of x could be a radical, a rational, an inverse graph. F of x could be just a plain old function that passed the vertical line test. F of x could be a log, an exponential. It doesn't matter what f of x is. It just matters that if it is f of x, it's a function. And remember, functions just passed that vertical line test, so we had quadratics. They were functions because they passed the vertical line test, right? No matter how many vertical lines I drew, they only crossed through once. And for every x, there can only be one y is the definition of a function. So when you draw vertical lines, every x has only one y because it doesn't cross through more than once. We get taught that in grade 10. So the graph of y equals f of x is transformed to the graph of y minus 2 equals f of x minus 3. So is this an actual graph? This y minus 2 equals f of x minus 3. Is that a graph? Should I plug it into my calculator and get a graph? No. This is a fancy way of giving me transformations, right? So the first thing I'm going to do is get into y equals. Y equals f x minus 3 plus 2. This is not a graph. This is stuff that affects the graph of f of x, but it is not a graph. Okay, that little f in it is not a graph. You cannot type it in. You cannot look at it. It is not a graph. It is the transformations that are affecting the graph of f. That's all it is. So I have this number here, I have this number here. Okay? So the transformations are written down here, but I'm going to state them anyways. Transformations always have to go in the order stretch, reflect, translate, like search. This is the order you always have to state them in. Stretch, reflect, translate. Currently we have no stretches or reflections because we haven't learned them yet. We only have translations or transformation. So this 3, is it a positive 3 or a negative 3 actually? What is my H? My H is actually positive 3 or negative 3? Positive 3, because it's x minus h. And what is my k? Just 2. So if I take my transformations, this 3 is a horizontal. So I have a horizontal translation. You cannot short form this. They will take off marks. Horizontal translation. You put HT, they won't even count it. Horizontal translation, 3 units where?
Right.
Right. Because it has to be right or left because it's horizontal, correct? Because it's a plus 3, it's right. So you wouldn't say horizontal translation minus 3 units left. You'd say horizontal translation 3 units left if it was negative, right? The negative makes it go left. Positive makes it go right. And 3 is the units that we're moving. Then we have a vertical translation. 2 units where? I heard someone say up. So these are my transformations in words. This and this, these are equal. These are the exact same. This is my transformations in an equation. This is my transformations in words. So if they give it to me in transformations in an equation, that's how they would write it. This is transformation in words. This one tells you in words. This one tells you in words. You just have to pick out the words. Right? These are equally the same thing. I can give you one or the other, and you can move your graph. Because it is not a graph. This, with that F in it, it is not a graph. It's a transformation. If I can get you to get on board with that, your life and transformations will be easier. Because people want to type this in. You cannot type that in. That is transformations. Words. Same thing. So mapping, it shows it down here, but let's prove why mapping becomes this. So my mapping is x, y, I'm just rewriting it down here to prove point, becomes, now I need to move 3 to the right. If I'm a little coordinate and I'm an xy coordinate, I want to move 3 to the right. I take my x coordinate value, my x, and I add 3 to it, right? And that would move me 3 to the right. So I'm going to go x plus 3. And then my y, vertical translation 2 up, I start at y, I need to go up 2. Boom, boom. So I'm going to take that y and I'm going to add 2 to it, right, to move it up. And that's how they got that mapping that matches that I'm rewriting. You use mapping when they ask for mapping, obviously, but the other places that you use mapping is whenever you're moving a coordinate. So if you're moving a single coordinate, you just use mapping, put that coordinate in for it, and poof, you have an answer, okay? If we're moving full graphs, we'll also still use mapping, because what are graphs made up of? Points, coordinates, correct? If I move a coordinate, I use mapping. If I move a whole bunch of coordinates, which is a graph, I use mapping, okay? And people at first will be like, I can just do that in my head. Yeah, because all I'm doing is vertical and horizontal translations, but soon I'm going to have vertical stretches, horizontal stretches, reflections in the x, and reflections in the y. Then it gets uber complicated. So we practice it even though it is easier right now if you don't. So it says here, so if the point 4, 6 is on the graph of y equals f of x, then the point would become 7, 8. Well, let's try it. Our mapping, we're moving a coordinate, so we're going to use mapping. X, y becomes x plus 3, comma y plus 2. And I'm going to put this in here. So I'm going to go 4, 6 becomes 4 plus 3, 6 plus 2. So 4, 6 becomes what? 7, 8. And it proves it, right? So we would have this graph where 4, 6 would be drawn on it, and now that graph gets moved to 7, 8, which makes sense because I'm going to be moving it 3 to the right and 2 up, which would get me to 7, 8, which you could just move, right? You could do it without mapping right now. We're going to do it always with mapping to practice mapping, because like I said, we're going to have 6 transformations, not just 2. So we have to be able to use mapping, or it gets really complex. Okay, next page. So here it says, describe how the graphs of the following relate to the functions of y equals f of x. Are A, B, C, and D graphs? Are they graphs? No, they have a little f in them, right? So they are literally just transformations, not in words, right? Transformations in an equation. So let's talk about this one. What is this one doing? It's with the x, so it affects the x. So is it a horizontal translation or a vertical? It's a horizontal translation. Three units what? Units right. It's in the bracket. I want you guys to try B, C, D. See how you do. B, does this affect the x or the y? Is it with the x? No, so it affects the y. So it is a vertical translation. Four units where? Up. I know in grade 11 I've let people get away with shorthand. I don't in grade 12 because you're going to just, they won't give you the marks if you do shorthand. So I don't want to set you up for something that's going to get you more marks. This one is a vertical translation. Eight units where? Down. This one is a vertical translation or horizontal, doesn't matter which one you list first. You just have to list both. Vertical translation. 4 units where? Up. And a horizontal translation. 7 units left. So do I even have any clue of what this graph looks like? No, they've given me no inkling of what f of x actually is, right? They're just saying, there's a function somewhere in this world. The function could, all of us, if I said, okay guys, what does the function look like? I guarantee you all would draw a totally different function. They'd probably all be quadratics because you would revert to last year. But they would be all different, right? Because they didn't give us a function, because that's irrelevant. They're just saying, if I give you a function and I give you this equation, what are the transformations that are happening? Okay? We're going to do the mapping now too, because I always just double follow behind. Wow, I'm struggling with the mapping. So, horizontal translation 3 units right. Does that affect the x or the y? It's horizontal. X. How do I move an x 3 right? What do I do to it? Add 3. Did you know that words and mapping are the same? So I consider this like words, right? Because it's just another way of giving you words. So what does that mean? That means words and mapping follow the same thing. So if I'm moving 3 right, I'm adding 3. Do you see how back here, though, it has an x minus 3? Because it's opposite when you pull it out of that transformation, right? Yeah.
So, can you use, if the words are mapping, could you use the x, y to plus 3y for describing the transformations?
Words and mapping are not the same, like, as you can interchange them. Words and mapping are the same in the fact that if you're moving 3 right, you're adding 3. If you're moving 7 up, you're adding 7. So like here, it's a transformation. If you look here, it's x minus 3, but we're adding 3 and moving 3 right. So the transformation equation is actually opposite. And so it's not that, if you guys understand, transformations will be easy. If you try and memorize, it makes it a little bit more complex. Like if you're like, x minus 3, do I go 3 right? Or like, is there 3 left? What is it? Oh, you know, like if you know that if it's coming out of the equation, it's always opposite because the equation is x minus h, then you won't make the oopsies. If you're trying to memorize, then you're like, is it the same or is it different? I can't remember, right? But why is it different? Because it's x minus h. So this would be x minus a positive 3. So that's why it's 3 to the right. We understand why it is. We don't memorize. So this one here, if I'm moving 4 up, is it going to affect my x or my y? X or y?
Y.
Y, because you're moving up. And how do I move up from a y?
+4.
Plus 4. This one, yes, that is with conviction, which is what I want. So here we have x, y, and we need to move 8 down. So our x stays the same. Our y is what?
Losing 8.
Is losing 8 or minusing 8. Said with conviction. All right, this one here, x, y, I need to move 7 to the left. So I'm going to go x minus 7, and I need to move 4 up. So I'm going to go y plus 4. So mapping is actually easier, I find, once you have the transformations listed, because you're just doing what they are, right? So people are like, I don't want to write the transformations first, I just want to go to mapping, I'm lazy. Totally fine. You might make oopsies, but up to you. All choices. Replacement is actually replacement. You are replacing it with something. So here says, what happens to the graph of y equals f of x if the following changes are made to the equation? So you take x and you replace it with x plus 2. So I go to this x and I'm like, nope. And I huck it across the room and I physically replace it with x plus 2. So now I have y equals f, and I took the x out, ripped it out, threw it away, and replaced it with x plus 2. What do we have now?
Translation, 2 units.
Yeah. Horizontal translation. 2 units left. Why are we saying units?
Because we don't have, it could be kilometers.
It could be centimeters, it could be
units.
graphic units, right? It could be whatever it is. We don't have units. The next one, we're going to take the y out of the equation, throw it across the room, and we're going to replace it with y minus 8. So the f of x stays the same, but the y on the left gets ripped off, thrown across the room, and replaced with y minus 8. I personally myself wanted in y equals every single time, so I followed the same rules. Because if I keep it in this form, then it actually is 8 up. You have to do the opposite when it's with the variable. Then you think, okay, well, where it's a variable, I do the opposite. If it's on the other side, I do the same. I don't like if it's and if it's. I just move it. So I'm like, I always wanted y equals. So I go, okay, y equals f of x plus 8. And now I know it's a vertical translation, 8 units where? Up. It's always the same, right? If you leave it on the left-hand side, you just think, okay, now it's the opposite. And then that causes brain power outages. So this would be a vertical translation. 8 units up. Now this one here says the point 2, negative 3 lies on the graph of y equals f of x. State the coordinates of the image point. If I'm moving a point, what should I use? Mapping, 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 mapping. If I'm moving a graph and moving multiple points, I use mapping. So what's the very first thing I should do here? Yeah. So I should get y equals f of x minus 8. Now I need to move it to mapping. So my xy becomes, and you can do the in-between stating transformation. Can't type that one in my calculator, it has an F in it. It's not actually an equation, it's just transformations, right? So what is this doing? Vertical translation, 8 units, there, down. So if it's vertical, it affects the y, and I want to go 8 units down. What am I going to do to it? Subtract 8. And then to find the new point, I'm going to just plug the old point into the xy. And then it becomes 2 and negative 3 minus 8, which becomes 2 and negative 11. You try B. xy becomes x. Now I'm moving 7 to the what? Horizontal translation, 7 units to the right, so I add 7. And a vertical translation, 5 units. Up, so I use move 5. Positive 5, so I get 2 negative 3 becomes 2 plus 7, comma negative 3 plus 5, which becomes 9 and 2. Now some people say I don't need to use mapping in order to find the point. True. But remember I told you we are preparing ourselves so that we may have all of the transformations as being hard. So we need to practice when it's easy and get the easy down so that when I put all of them together it's not overwhelming. Here it says a horizontal translation, 5 units left. And they want us to write the equation of the image. So it's y equals f. I need to move 5 to the left, so it's going to be what? X plus 5. And why is that? Because it's x minus negative 5, technically. Which is why it is x plus 5. At any point, have we actually seen what these functions are? We've never seen a function yet. We just know there's functions and we're doing things to it. Like there hasn't been a graph yet. Okay, vertical translation 3 units up. So y equals f x plus 6. And this one a horizontal translation m units right. So y equals f. To go to the right I have to actually minus my positive m. Because it's x minus whatever it is, right? And then p units down. We're going to flip over. Finally a graph. Finally. We're moving a graph, which means we're moving what? More than 1 point. So what should we use? This will be embedded in your soul by the end of it. Yeah, we should use coordinates, and we should use what? Starts with an M. Mapping. Every time you a coordinate or a whole bunch of coordinates, you use mapping. Now I know it's going to seem ridiculous today because we're only moving it 2 to the right. So I could just move this 2 to the right and go like this. Now what happens is people will start plotting dots. What you need to do is you need to plot the dot and then plot the next dot and then put a line between them. Because what happens is sometimes people will have all these dots on it. And yes, we're moving it 2 to the right, so it's easy to figure out how to connect them. But sometimes you're flipping them about the x, about the y, and then you're stretching them horizontally, you're stretching them vertically, you're moving them 2 to the right, 5 up. And you go plot all your 5 dots, and then you're like, uh-oh, how do I connect them? And you're like, meh. So I'll have people connect 5 dots wrong. You'll have the right 5 dots, connect them incorrectly. So please, find a dot, connect it. Find the next dot, connect it. Find the next dot, 2 to the right from this one, connect it. 2 to the right from this one, connect it. So can we do it without mapping? Sure, because this one's easy. But we're going to put them together, and then we're going to have to actually do our mapping when we have a whole bunch of them. So we're going to practice mapping for this next one. So, yeah, it's a real thing sometimes. Do you want a ruler? I'm not joking. I have one. Do you want a ruler?
Not yet.
Not yet.
Probably not a test with this.
Okay. This one here, we're going to subtract the 2 over. So let's make our mapping. X, Y becomes, X, what do we do? Is it 3 units to the left or 3 units to the right? Left. So we're going to minus 3. And then our y, is that 2 units vertically translation, 2 units down or 2 units up? Down. So we're going to subtract 2 because that's going to move it down. Now to show how we would do this with mapping, I'm going to take a couple coordinates and then show you how we could get around it. But this is 1, 2, 3, 4, 5, 6, negative 7, and 2. And then we fill it in. Negative 7 minus 3, 2 minus 2, and my new coordinate is negative 10, 0. A little bit off the graph. Then I find my next one. It's at negative 5 and 2. So I get negative 5 minus 3. Oops. Negative 5 minus 3. 2 minus 2. So I'm going to get negative 8 and 0. And then I connect to them. And I go to my next one. It's at 1, 2, negative 3, and negative 4. And it's going to become negative 3 minus 3, because I'm always just plugging it into my mapping, right? Negative 3 minus 3, negative 4 minus 2. So it's going to be at negative 6 and negative 6. Oh, why did I do that? Okay, these. Now would I technically have to do mapping for this if I'm moving 3 left, 2 down? No. I'm going to do the rest without using mapping, but I want to prove to you that mapping works, right? So if I want to move 3 to the left on this one, I'm going to go 1, 2, 3, and 2 down. I'm here. Then I connect to them. And 3 to the left on this dot here. 1, 2, 3, and 2 down. So now I'm here. Well, let's do straight. Okay. These are the last two we're going to go over, then we're going to stretching. So here, this is what I want you to do. I want you to state the coordinates of the image point, and then I want you to tell me the transformations, like in words, because I can give you mapping and ask for the transformations as well. So the catch between grade 11 is we give the equation and then ask for the transformations. In grade 12, we can give the transformations, ask for the equation, ask for the mapping. We can give you mapping, ask for the transformations and the equation. You can ask for any of them, so you need to know them all. So I want you to try example 6, and then example 7, they just want the transformations. Try them out. Could I plug these ones into my calculator?
Yes.
Yes, would I suggest you do that? No, just look if it affects the x's or the y's. But these I could plug in because they're actually, this is a quartic function, that's linear, this is an absolute, that's a radical, rational radical, kind of crazy. So these you could actually type in because they don't have x. So you have to see how they change compared to each other. Okay, try out example 6, 7, then we move on to stretching. So when they give you mapping, if they give you a coordinate, that would be the nicest thing ever because you would literally just fill it in. But often if they give you mapping, they're going to ask for the transformed form or the transformation. So that equation with the f in it or the transformations. So we plug this in, and our coordinate that we get is negative 10, 9. Now, if we look at this, what are our transformations? We have a horizontal translation, seven units right, and a vertical translation, four units up. No one correct me? No one correct me?
Why is it right?
Why is it right? It shouldn't be right, because we're doing what? We're subtracting 7. So we have an x-coordinate. We're subtracting 7. Here I'm walking, subtracting my 7. Which way am I going? I ran out of room. I'm going left. Remember, words and mapping are the same. I'll have to do this. Words and mapping are the same. So if it's minus 7, I'm going 7 left, right? Because I'm physically moving 7 to the left. Now, equation-wise, if we did equation, we would have y equals f, x what? Would I add 7 or minus 7? Add 7 or minus 7? add 7. Make sure you're paying attention. And then I have to go 4 up. So I add.
Yeah.
Yes, you are going 4 up. This is true. Thanks for the agreeance. So this one's negative 3, 5. So we're going to get negative 3 minus 6, comma 5 plus 1. And so I get negative 9 and 6. So this I have a horizontal translation. Units where I'm minusing 6, I'm going 6 units to the what?
Left.
And then I have a vertical translation. 1 unit. Up or down? Up, because I'm taking my y and I'm moving it up while I'm adding, right? I'm adding 1, so I'm moving it up. My equation, however, would be y equals f. I need to go 6 units left. So what am I going to have? X and 1 unit up plus 1. These ones I set you up for a little bit because I'm going from equation to equation, not a transformation equation. This doesn't have an f in it, does it? So when it doesn't have an f, I'm going from this equation to this one, and I see what changes. So I had an x to the 4, now I have an x to the 4 plus 3. So what is this going to cause me to have? Vertical translation. Three units. Up. This one tricks people. They'll tell me, vertical stretch, if they knew that there was a vertical stretch, they'll tell me it's 3 down and it's 1 to the right. Does this have an f in it? No. I'm going from this equation to this equation, and you're telling me what's changed, correct? Did the 6's change?
No.
Did the 3's change? The only thing that changed was this x became an x minus 1, so that's the only transformation I have. Horizontal translation. One unit, right. Set. This one, I have an x, it becomes x minus 6, and I had nothing at the back, and I have plus 2, so both of these affect, correct? So I have a horizontal translation. Six units, right? And a vertical translation. 2 units up. This one people get thrown off. This is an absolute value function that moved. This I could type in my calculator too. But what's the only thing that changed? My x became an x plus 1. Doesn't matter that it's in the bottom. No. And then this plus 3 at the back. So those are the things I have to describe because that's the change that happened. So I have a horizontal translation. One unit, what? And a vertical translation. Three units. Then I'll flip it over. Oh, I lied. Here it was left there. Why did I keep All right. Reflections. We're going to skip this. Go here. Here. I did an excessive amount of examples. Okay. Reflections. So a reflection is a mirror image about a line or axis. Invariant points are points that do not move. This is very important. They might just ask you for how many invariant points or what are the invariant points. The invariant points are the points that do not move. From the original to the transformed graph, they stayed the same. They were not moved. They just became the same thing, right? So if I did mapping, 3, 0 stays 3, 0. Like it doesn't change. So here we talk about reflections in the x-axis, which is actually the only reflection we talked about last year, was a reflection in the x-axis. So that was where we had y equals f of x, and then we got a negative in front of the whole function. A negative in front of the entire function. And that's all you had last year, because you would have a quadratic that was concave up, and then remember when it had a negative leading coefficient, it was concave down? Which axis was it reflecting on? Yeah. So when it actually affects the y values, it reflects on the x-axis. So if my y values are positive, they become negative, and my negative y values become positive, and that's how you get that reflection. My hand is up and my hand is down. My hand is up, my hand's down, right? So it ends up reflecting it on the x-axis. When it affects the y's, that's what happens. Now, here it says y equals f of x equals x squared minus 4x plus 4. They're saying, well, f of x becomes negative f of x, correct? So if my equation is f of x equals, if it's this, f of x equals this, and they want negative f of x, well, all I do is I take this f of x, and I put a negative sign in front of it, right? That's what they want. They want negative f of x instead. So I'm going to get negative f of x equals x squared minus 4x plus 4. Remember, f of x is just a fancy way of saying y, and the only reason why we use f of x to g of x or h of x or m of x is because now we can have more than one graph on a Cartesian plane, and we want to be able to tell which graph is which, right? That's the reason why I use function notation over a y. So I always wanted in y equals or f of x equals. So how do I get rid of this negative 1 in front? Because that's technically what it is.
Divide by negative 1.
And you can divide every term by negative 1. So you actually get f of x equals negative x squared plus 4x minus 4. So we want to sketch this one. So type x squared minus 4x plus 4 into your calculator. Yes. They just put it on, so it should just, they say it should just rewrite itself. We shall find out. So when you type it in, find the vertex. Is there a vertex button? Anyone remember? Maximum or minimum, yeah. So x squared minus 4x plus 4. If I go zoom and then 6, it sets it to that standard window. Zoom 6, just in case your window's all wonky. Now, there's no such thing, whenever we want to calculate something, we always go second trace, because the second button gets me what's above the trace button, which is calc. So I'm trying to calculate something. So I go second trace. Well, there's no vertex option, but the vertex is just the min or the max, correct? And in this case, because it's concave up, it's the min or is it the max? Min. So we're going to go to number 3. And then we go on the left, we hit enter. We go on the right. We hit enter, and then we hit enter again. And this, do you see this? E to the negative 12. Does that coordinate look like it's at 2 and 3.1? 2 and 3.1 would be somewhere up here, right? Does it look like it's there?
No.
What does e to the negative 12 just mean? 10 to the negative 12. So this is like 0 decimal 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, I don't know, 0, 3, 1, blah, blah, blah. An aggressive amount of zeros after the decimal, which is just literally a fancy way of saying what?
0.
0. So this is at 2, 0. So if you see e to the negative anything, that's just 0, right? So this has a vertex at 2, 0. How do I get more coordinates? Yeah. Second table. It's me more coordinates. And I want 2, 0. So I want stuff on the opposite sides of 2, 0. So I'm going to make it in the middle. So I have 2, 0, 3, 1, 4, 4, 5, 9. 2, 0, 3, 1, 4, 4, 5, 9. 5, 9 is round off spots. Then I have this, and then I have this, and I have this. And I don't draw my arrows aggressively 70 feet above this last coordinate. Why do I not do that? Why do I not just go whoosh, willy-nilly? Yeah, if you draw them wrong, it's wrong. We don't actually know where those go unless we actually hit the 5, 9 and whatever, right? So you just want to draw your arrows a little bit above the last coordinate you plotted. If you want to make it, we want to cover the whole graph for sure, but you can't just go like, yes. Like, I don't know if that's right. You just willy-nilly drew, like, you drew double the amount that you had already drawn just by guessing. Sheer guess. Try and draw straight. Okay? So we do want to put arrows on the ends, and we want to extend them a bit, but we don't want to aggressively extend them way past what we have. And we want to label this f of x. Okay? We're labeling that f of x.
F of y equals f of x or just f of x?
F of x. Now we want to actually sketch the y equals negative f of x. So this is what I always say. Is this negative in with the x? If it's in with the x in the bracket, it'll affect your x variable on your mapping. If it's in front, it won't. So this for mapping is going to be x, y becomes x. Nothing happened to the x. You see how the x is just sitting pretty? Nothing happened between the x's there. So my x is going to stay, comma. And what's going to happen to my y? Multiplied by negative 1. And when it affects my y, it's not my eyes, it's a reflection. I'm going to write this down, bottom 2, by the right here anyways. Reflection in the x-axis. Because think about it. If we are negating our y's, that means all the positive y's are going to become negative y's, correct? Conversely, if we had negative y's, they would become positive y's. So, our mapping is x, y becomes x negative y. So if I take my first one, which is 0, 4, and I plug it in, I'm going to get 0 and negative 4 now. And I plot that one. It's down here. Then my 1, 1 is going to become 1 and negative 1. It's down here. Then my 2, 0 is going to become 2 and negative 0. Is there such a thing? So this is staying the same, correct? Has it changed? Did it move? Did anything happen? And then here I have 3, 1. It's going to become 3, negative 1. And some people might say, this is excessive. I don't need to do this. Remember, we're going to put them all together, and then you're going to be in trouble if you're a person who kept skipping all the things I told you you have to do and learn how to do really well. So we're going to put them all together, and then it's going to be nasty if you didn't practice what I'm telling you to practice. So we have 3, negative 1. And then 4, 4 becomes 4 and negative. And that looks like it's reflected in the x-axis, right? If all we have is a reflection in the x-axis, what's your invariant point going to be on? Yeah, y equals 0, the x-axis. Why did you say y equals 0 when it's the x-axis? Which is completely accurate. I'm not mocking. How do you know that? Yeah. And when it's y equals 0, what's every value on this x-axis? What's every y value, sorry, on this x-axis? 0. So it's exactly what Alyssa said. She's completely correct. What they'll say is x-axis, but sometimes they'll actually say in the line y equals 0. These are the same thing. Interchangeable. Yeah, that is the line y equals 0. If you draw the line y equals 1, it'd be a horizontal line right above it. Y equals 2, a horizontal line, y equals 3, a horizontal line. Everyone wants to say that's x equals 0, but actually the only thing that isn't 0 is x's. X's are all different numbers. Your y's are all 0. We're going to get to that later, but look at Alyssa. She just like slammed that one. You got it. What about this one? What's this vertical one? The y-axis, and what is its equation? X equals 0, because what's the only thing equal to 0 on this y-axis? Zeros are all the x's, right? Our y's are what's changing. All right. So state the coordinate of the invariant point or points. Well, this one would just be 2, 0. It's the only one that didn't change. And how does the graph of y equals negative f of x compare to the graph of y equals f of x? It's a reflection in the which axis? So if it affects your y values, it's actually a reflection in the x-axis, right? Because our positives become negatives and negatives become positives. It's a reflection in the x-axis. I'm telling you, you need to be able to answer these questions like this, because we're going to put them all together. And if you're like, a reflection x, or reflection y, or reflection x, I don't know. That's dicey. Because trust me, they're going to have every answer, and so will I, on the unit exam, of every oopsie option. So if you're like, I don't know if it's reflection or x or y, do you think every answer, one of them will have reflection in x, one will be y, one will be x, one will be y, for the multiple choice? Yep. So you need to know it. Okay. To go to sketch this one, we're going to take our coordinates. So I'm going to take this coordinate from here, this one, and this one. Could I take more? Is taking more better? Yeah, the most amount of coordinates you can take will make the most accurate graph when you do all your reflections and stuff. But we really only need these for reflections. This is a negative, which means it's a reflection in the x-axis. So I'm going to get xy becomes x comma negative y. So if I take negative 4, 0, it's going to become negative 4 comma negative 0, which means it's staying the same. Also, this one's going to stay the same, because when you reflect on the x-axis, if the only things that reflect on the x-axis are your invariants, are going to stay, because a negative 0 is 0. And then we check our other one. It's at negative 1, 4. It's going to become negative 1 comma negative 4. So tomorrow you're going to have homework on vertical and horizontal translations, and I'm going to give you a little sheet on practicing firms, commas, and binomial theorem, because we need to keep practicing those till the test, right? And we won't stop. We'll keep practicing them after that too. They never leave.